Okay, let's continue on working through the problems in Ross's first course in probability. We're now on to 17, 18, and 19. Let's get on with it. All right, so number 17, see if we can recognize old problems within these new problems. 7 different gifts are to be distributed among 10 children. So different gifts. How many distinct results are possible if no child is to receive more than one gift? So different gifts means they are distinguishable, and no one can receive more than one means we are sampling without replacement. All right, so what we really have is 7 distinct gifts, and we have 10 different choices for the first gift. And after that, so one child has received it, she can't receive another, so now for the next gift we have 9 choices, then 8, then 7, then 6, then 5, then 4. So this is a permutation of 10 items taken 7 at a time, or 10 factorial over 10 minus 7 factorial. Oops. All right, let's move on to number 18. A committee of 7, consisting of 2 Republicans, 2 Democrats, and 3 independents, is to be chosen from a group of 5 Republicans, 6 Democrats, and 4 independents. So we have 5 distinguishable Republicans, because people are distinguishable, 6 distinguishable Democrats, and 4 distinguishable independents. From the 5, we are going to choose 2, right? So we aren't ordering the people on the committee, so that's a combination. 5 choose 2. And then the next step, so we do multiplication, of the 6 Democrats, we are going to choose 2. And then the last step is from the 4 independents, we are going to choose 3. So we are taking steps, and each step is a combination, because order doesn't matter within the committee. Okay? Moving on to 19. From a group of 8 women and 6 men, so I'm going to write these things down for me. A committee consisting of 3 men and 3 women is to be formed. All right, that sounds very familiar and something that we've done before, but in this problem we're going to put some restrictions on it. How many different committees are possible if 2 of the men refuse to serve together? So there are 2, let's say we'll call them M1 and M2. They will not be on the committee together. So we actually have 2 scenarios here. Either one of them is on the committee and the other one isn't, or neither of them are on the committee. So since those are 2 different scenarios, that involves not a step but a choice, so that's a plus. So we have no restrictions on the women, so the first is to choose the 3 women from the 8. So step 1, we're going to choose, since it's committee, we don't have any ordering of their roles. Of the 8 women, we're going to choose 3. Okay, in the first scenario, let's assume neither of the men are serving on the committee. So that really means we only have 4 men to choose from, not M1 and M2, and we're going to choose 3. So that is neither serve. Or, so now we're going to have this plus, exactly one of them serves. All right, so we actually have 2 choices there. So 2 choose 1, right? It's either M1 or M2. Then of the remaining 4, because we're going to remove those 2 now from the pool, we'll choose the remaining 2. All right, so this first step here is choose which of the 2 men will serve, choose the other 2 from the remaining 4, and then of course no restriction on the women. 8 choose 3. All right, not so bad. All right, let's look at B. 2 of the women refuse to serve together. Well, this is really the same problem as 8, so let's see. I think you should hit pause, make sure you do it, and then come back and look and see if we do it the same. So now let's look at neither of them serve, which means of the 6 that aren't W1 and W2, choose 3. And then of the, how many men we have? 6 men, choose 3. That's if neither of them serve. Or either of them serve. So of the 2 women, choose the one that is on the committee. Of the remaining 6 women, because we're going to remove those 2 from the 8, choose the remaining 2. And then of the 6 men, choose 3. All right. Lastly, let's look at C. 1 man and 1 woman refuse to serve together. Well, let's look at the case first where neither of them serve. So remove each one of them from the pool, and now you have 7 women. Choose 3. You removed the 1 man that refuses to be on the committee with the woman. So now we have 5, and we choose 3. So that is if neither of them serve. Okay, but now we can't do this 2 choose 1 because the sizes of the men and women in their respective groups aren't the same. So the first case will be that the woman serves. All right? So there's only one way that happens. Then of the remaining 7 women, choose 2. And then the men, that doesn't include the woman that won't serve with that man, so there's only 5 of them, choose 3. That's if the woman serves that refuses to serve with the man. In the case where the man serves without the woman, there's only one way he can be chosen. Then of the remaining 5 men, choose 2. And then we've removed that pesky woman, so now we have 7 women, choose 3. And that's it. If you have any questions about this video, these problems, or any others, email me.